Okay, so again, our locus definition is going to be the set of all points equidistant from a focus to a directrix. For a parabola, we're going to call the center point the vertex. And I'll write that down again for you in just a minute. But our center point, oh good grief, for a parabola is going to be the... Okay, so again, the distance from the focus to the parabola and from the directrix to the parabola are equidistant or equal or the same. Okay, so that's what the locus definition is saying, is that in order to draw these parabolas, our distance from our focus to our parabola and parabola to directrix are the same. Now that's more of a computer-generated drawing thing. We won't actually use that to draw the parabolas, but that's how they're drawn, again, when you're talking about some kind of computer generation. Okay, what's special about our parabola is that it only has one squared term. Okay, so when you're looking at the formula for a parabola, you will either have x squared or you will have y squared, never both. There is only one squared term. Okay, so when we talk about our general form of an equation for these, and again, we've written this down 4 times now. Here's our general form right here. And what we need to know about the general form for a parabola is that it will only have one squared term. Only have one squared term. So either A is equal to 0 or B is equal to 0 with a parabola. Okay, and there will be a question on the test next week that asks you, how do you know each conic section is each conic section? So for the parabola, when you're looking at your general form, you will know because either A is equal to 0 or B is equal to 0. Okay, so for example, if A is equal to 0, then you don't have x squared, you only have y squared, so one squared term. Or if B is equal to 0, you only have x squared, not y squared. Okay? All right, so that's how you'll answer it, is that in this case, either A or B is equal to 0. Okay, with parabolas, we can either have a vertical or a horizontal parabola. When you're thinking about these, it's kind of opposite from what you would think. So think about just your regular parent function of y equals x squared. And y equals x squared is just your regular old parent function of your parabola. So if x is squared, then you're going to have a vertical parabola. Okay, so just think about your normal parent function. Again, it's a little bit opposite from what you might think. So just compare it to your parent function. So if x is squared, you're either going to open up or down. If x is squared, you're either going to open up or down. And here's how you know which one. I'm going to go look at the number that is in front of y over here, which they're going to call 4p. And if 4p is positive, you're going to open up. And if 4p is negative, you're going to open down. You may have. Yeah, you may have done this with conic sections. Okay. All right, let's go horizontal. So a horizontal parabola looks like this. And this is what makes them special with conic sections. Because if I look at this horizontal parabola, it is not a function. But because it's a conic section, that's okay. It's okay for it to not be a function. Okay. All right. If y is squared, then it's going to be horizontal. So it's either going to open to the right or to the left. And again, you know which one is which because you either have positive 4p or you have negative 4p. Okay, so to the right is positive and to the left is negative. So what's squared is kind of opposite from what you would think. X is up and down, y is left and right, but then the positive negative is in the direction you would think. Positive is up and right, negative is left and down. Okay, and we'll take a look at all of these in just a minute. All right, our vertex, again, is the same as the center for the others. So when we're talking about a parabola, your center is your vertex. So again, x is from x and y is from y, an opposite sign. Okay. All right, p, so I'm going to solve for p. I'm going to take 4p and set it equal to that number, is going to be the distance from the vertex to the focus, and you're going to measure that distance in the open direction. So in the direction that you said that it's going to open, I'm going to measure from the vertex that distance and find the focus. So to find the focus, measure in the open direction. Okay, then we're going to have a directrix. So in this one, here's my vertex, here's my focus, they are points, and then I'm going to have this line that's a directrix. And I'm going to measure the same amount, so P, in the opposite direction. Okay, so for example, and again I'll show you one of these in just a minute in drawing form, but if I went up to find the focus, I'm going to go down to find the directrix. Okay, the last thing that I need for a parabola is the width, and we call this the focal width. And we call it that because we're going to measure it from the focus. We're going to measure it from the focus. And to find the focal width, I'm going to do 2 times p in both directions. So this direction over here is 2p, and this direction over here is 2p. Now the whole way across, so if I add them together, so 4p is what we call the latus rectum, because somebody that created math does not like pre-cal teachers. And today we get to talk about p and the latus rectum. Good deal? I don't know why they call it that. I get asked every year, why is that the name? I'm like, I don't know. Good. Okay, let's go put some things into practice. Again, you've got some examples here that UT has given you. I am not going to work those so that you have extra examples. I'm going to go work some off of your homework. Okay, so grab your homework page, turn over to your homework page, and grab your graph paper. So you're going to want to have your graph paper for this. I'm going to give you a clean sheet of graph paper for the test on Wednesday, Thursday. For your test on Thursday, I'm going to give you a clean sheet of graph paper so that you can use it while you're working on the computer. Okay. On this first part, I'm sorry. Yes, I do. On this first part, let's omit number 2 because it looks yucky. And I don't like yuckiness. You're welcome. So let's omit number 2. Hold, please. There we go. All right, number 2 looks kind of, ew, gross. Let's take it off. And let's take off 6, 7, and 8. So if you took a picture of the assignments on the board yesterday, that's a change, because yesterday I said to do 1 through 4. But 2, ew, gross, don't do number 2, okay? I hate to hurt its feelings, but wow. Yes. Yeah, absolutely. Yep. Okay. All right, on the next section, you're welcome. I would like for you to do all of them except for 13 and 14. So you can omit 13 and 14. 15 through 18 are the puzzle problems. Those are really good, so do all of 15 through 18. They don't take very long. And let's omit 19 and 20. So you don't really need to do all the word problems. But 21 I've seen before on some stuff, so give 21 a try. And then flip over to Exploration 2.3.2 again. Exploration 2.3.2. and do number 9. Okay, so far we've done number 7, the ellipse, 8, the hyperbola, and now 9, the parabola on exploration 2.3.2. So flip over to exploration 2.3.2 and try number 9 on there. Okay? All right, now go back because we're going to do number 1 together. All right, back to the homework. And let's try number 1. All right, grab one of your graphs, and let's label it Parabola Homework number 1. All right, Parabola Homework number 1. And away we go. Okay, let's start with the direction that we're going to open. It's always a nice way to start. So on number 1, x is squared, kind of like my parent function for x squared. So I'm going to say this one either opens up or down. Okay. Here's my number that's in front of y right here. So that's going to be my 4p value. And because it's negative, it's going to be down. That's right. Good. Very good job. Okay. All right, let's go and look at 4p. So the negative is directional. I'm not going to use it when I go to look at my distance because I don't want you to overthink it. So some years I have people say in this case that p is -4, so to go down -4, they start going up. Do you see that? Okay, so don't overthink it. Just let p be a distance, and I'm going to say that p is a distance of 4. Okay. So you can, after you do the directional part of the positive negative, you can let the sign go. Okay, let's go find our center, or again, with a parabola, we call that the vertex. There will just be one. And so with my vertex, I'm going to pull x from x, opposite sign, and I'm going to pull y from y. Now, there's nothing with y, so what am I going to use as a placeholder? 0, that's right. Okay, so on my graph, I'm going to graph the point 3, 0. It's really best on these if you graph as you go because it'll show you the directional part of it. Okay, next I'm going to go and find the focus. For the focus, I'm going to go in this direction, this many. Okay, I'm going to go in this direction, this many, from the vertex, or from your center point. So from my vertex, I'm going to go down 1, 2, 3, 4. So my focus is going to be 3, -4. Okay, the focus is also a point. Focus is also a point. Okay.
So if it's up, you just go up, right?
That's right. That's right. Good. Okay. All right, next I'm going to go find the directrix. The directrix is a line. Directrix kind of sounds like something from Harry Potter to me, but we're going to go in the opposite direction, still this many. Okay, so I'm going to go in the opposite direction, this many. So if I went down to find the focus, where am I going to go to find the directrix? Up, that's right, good. So from my vertex, from my center, I'm going to go up 1, 2, 3, 4. And I'm going to draw it as a line, and I draw it with my highlighter just so it looks a little different. You don't have to. Okay, there's my line. My line's kind of curvy. No judgment. Okay, to name it, I'm going to name a line. So a line that crosses the x-axis is an x equals line. The line that crosses the y-axis is a y equals line. So what do I have on this one, x or y equals? Y equals, good, because we're crossing the y-axis. Where? Where are we crossing the y-axis? 4. That's right. Good. So my directrix is going to be at y equals 4. Okay, now the last thing I need is the focal width. The focal width, again, is 2p, which in this case, p was 4. So my focal width is going to be 8. Now what the focal width is doing is telling me how wide to make my parabola. So I could have a little bitty skinny parabola right here. I could have a super wide parabola over here. I need to know how wide to make it. So when I look at this, I'm going to measure now left and right so it will show me my width. Now I'm going to do that from the focus, and I'll show you in just a minute why that's important. So from my focus, I'm going to go 8. I'm going to run off my graph. That's okay. 1, 2, 3, 4, 5, 6, 7, 8. You do not need to name these points. These points are just for the drawing. And then I'm going to go this way. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and again, that's giving me the width of the parabola. Okay, so that's how I need to go left and right. So at this point, I've got something in every direction. So from my vertex, I've gone down, I've gone up, I've gone left, and I've gone right. So I've got something in all 4 directions. Okay, and now I can just connect from my vertex out to my focal width, and my vertex out to my focal width. Okay, it's important that you measure the focal width from the focus, because if I accidentally measure it from the vertex and have a point here and have a point over here, when I connect, what am I going to have? A line. That's right. Good. So it's important that you measure the focal width from the focus so that you have a parabola. Okay. Okay, questions on that one? Okay, one more. Let's go take a look at number 9. So number 9, we're going to start with changing into standard form, very similar to how we changed into standard form with the ellipse and the hyperbola and the circle. The biggest difference on this is that I only have the 1 squared term. So I'm only going to need to complete the square with one of my variables. So on number 9, I only need to complete the square with y. Do you see that? Okay. So instead of getting all of my x's together and all of my y's together and moving anything else over to the other side, I'm going to get all of my squared term together, so in this case y, and then I'm going to move everything else, including the x, over to the other side. And when I do that, it will change their signs. Okay, so get everything that has squared term over on one side, everything else over on the other side. Okay, let's go ahead and complete the square. So same process we've been doing. If there's a number in front, take it out like a common factor. In this case, there's not. I'm going to bring down my y. I'm going to take half of my middle term, including the sign. What's half of -6 going to give me? Good. And then I'm going to square to fill in the blank. What's -3 when I square? 9. And if I add 9 to one side, I need to add 9 to the other side. If you've taken something out like a common factor, be sure to multiply that back in. All right, that's going to give me 36x minus 108. Now, if you will notice on your formula, on both formulas, I have my 4p value taken out like a common factor. So I'm going to go ahead and do that now. I'm going to take my 36 out like it's a common factor. And 108 divided by 36 gives me 3. Okay, that right there is your standard form. So finding the standard form for the parabola is a little easier than doing it with the hyperbola and the ellipse. You don't have to make it equal to 1 or anything. Okay, let's go ahead and graph. In this case, y is squared, so I know that this is either going to open to the right or to the left. Okay, which one, right or left? Right, good. How do we know right? That's right, because that 4p value right there is positive. So we know that we're going to open to the right. Okay, let's go ahead and find p. So if 4p is 36, what's p going to be? Just 9. Okay, my vertex is my center point. I'm going to get x from x and y from y and use the opposite sign. This time they come out to be the same. It doesn't always happen. It's just kind of a fluke. All right, grab a graph paper. This one's going to be parabola number 9. And I'm going to start with a point at 3, 3. Okay, to find the focus, I'm going to go in this direction, this many. Okay, I'm going to run way off my paper on this one. That's okay. Well, not way off on this one. In just a minute I will. 1, 2, 3, 4, 5, 6, 7, 8, 9. Puts me over here. So there's my focus at 12, 3. Okay, so I went to the right 9 to find that. Okay, if I went to the right 9 to find the focus, where am I going to go to find the directrix? Left, that's right. Good. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, that's going to be a line. Mine get kind of crazy. Like that. Okay, x equals or y equals this time? X equals, good. X equals what? Yeah, -6, good. Okay, my focal width is crazy on this one. How big is my focal width going to be? 18, yeah, good. All right, I'm going to count that from the focus. And again, this tells me how wide to go. So I'm going to go from my focus right here. I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I almost ran off the page. This one's very wide. It's okay. It'd be nice if they made them 10 by 10, but they don't. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Way down here. Huge. Massively huge. That's okay.